This is lesson 12.1, trig ratios, part 1. Our objectives for today: I can define the sine, cosine, and tangent trigonometric ratios. I can use the sine, cosine, and tangent functions to solve for an unknown on a right triangle. Trigonometry is the study of the relationships between the sides and angles of a triangle. Now if we look at this triangle they gave us, there's this weird symbol in the corner that represents an angle, and it is called theta. So we will use that to represent an angle that we don't know how many degrees it is. And we label all of the sides of the triangle in relation to where the angle is that we're talking about. So if theta is here, opposite of it is across, opposite. And then you look for the 90 degrees, and opposite of that is the hypotenuse, opposite of 90 degrees. And then whatever side is next to theta that we haven't already covered will be called adjacent, which is next to. Because the ratios for certain lengths and angles will always be the same, we can calculate missing side lengths given an angle and one other side on a right triangle. The trick to remembering them is the term SOHCAHTOA. That's going to be super important that we remember that. When doing these problems, always figure out which angle you're using. So we have theta right here, and then opposite of theta, you go straight across, opposite of it is the opposite leg. And then look for the 90 degree. Here's the 90 degree, which means the hypotenuse is across from that. And then whatever you have left over is the adjacent leg, which is right next to theta. The first ratio we're going to go over is SO. Another way we can write that is like this. And sine is the ratio of the length of the opposite leg to the length of the hypotenuse. So sine of theta, it's always sine of the angle. Okay, so sine of theta equals the opposite over the hypotenuse. So this is just a ratio to help us figure out missing side lengths, and O is opposite, H is hypotenuse. When we use SO, we're saying the sine of theta is equal to the opposite leg over the hypotenuse. Next we have CA, which is the cosine, equals the ratio of the length of the adjacent leg over the hypotenuse. So cosine of theta, the trig ratios always get to have the angle next to it. Cosine of theta is equal to the adjacent leg over the hypotenuse. The last one we have is TOA. So tangent is equal to the opposite over the adjacent. So tangent is the ratio of the length of the opposite leg over the adjacent leg. So tangent of theta equals the opposite over the adjacent. Alright, when using trigonometric ratios, please make sure your calculator is in degrees. So if you do these problems along with me and you get different answers than me, it's quite possible your calculator is in radians and not degrees. To change that, you just click the button on your calculator that says mode, arrow down to where it says degrees and radians, and make sure degrees is highlighted, not radians. So example 1 wants us to solve for x, and to do this, the first thing we need to do is label all of the sides. This is the angle they gave us. So we have our angle here, which is like theta. We have the 90 degrees written, and then we have an angle they didn't write anything on. We're not going to worry about that. If this is my angle, then opposite of it would be this side over here. And then this 90 degrees down here, if I go opposite of that, that would be the hypotenuse. And then the side that's left over, it's next to the angle, that would be adjacent. But if I look, I don't have any numbers on adjacent here, but I do for opposite and hypotenuse. That will help us figure out which of our trigonometric ratios we should be using. I'm going to use O and I'm going to use H because they are the two sides that had numbers, or it's the missing side. A doesn't offer us any information, so we're not going to use it. Alright, let's write our tricks back down. So, ka, toa. So we want to look to see which one uses both O and H. And if I look, that would be so. Alright, so if we use so, the sine of our angle, which is 20, equals the opposite side, which is 410, over the hypotenuse, which is x. Once you get to this point, let's go ahead and put this over 1, so we have two fractions. Now we can just cross multiply. So sine of 20 times x, sine of 20 times x equals 410 times 1, so just 410. And then we just balance and solve. This sine of 20 is just a number, so I can divide both sides by the sine of 20. And x equals, we do 410 divided by sine of 20 in your calculator. If you need help finding that at all, just let me know and I can let you know depending on your calculator where it is. If you have a TI-84 Plus like me, it says sine, cosine, and tangent above 7, 8, and 9, up a couple of rows. On some older calculators, you have to click a button that says trig, and then you'll be able to see them. If you have any troubles at all, just let me know and I'll help you with your calculator specifically. But if we go ahead and do 410 divided by the sine of 20, that will give us our answer, 1,198.8. And when we use the trig functions, we are going to end up with decimals, so that's okay. So that's that side length. Alright, example 2. They give us 35 degrees. That's the angle we will use. So from 35 degrees, if I go straight across, that side is the opposite side. And notice that we have no numbers and we're not asked to find anything about that side. So we're not even going to use it, but we will still label it. Look for the 90 degrees, go straight across from it. That is the hypotenuse, which has an x there, what we're trying to find. So I know I will use this side. And then the side that's left over, it's right next to our angle, so that is adjacent. It has a number, so we will use that side. So that means we will be using A and H, which if we look at our 3, the one that has A and H is ka. So we will be using cosine for this problem. So ka. Alright, so cosine of our angle 35 is equal to A, which is 515, over H, which is x. Let's make it a fraction and cross multiply. So cosine of 35 times x equals 1 times 515, which is just 515. And then we balance and solve. Cosine of 35 is just a number, so I can divide both sides by the cosine of 35. I don't type that in my calculator yet. Just write it. Alright, cosine of 35 divided by cosine of 35 is just 1, so I'm left with x equals, now this is the part you type in the calculator, 515 divided by cosine of 35, press enter, you get 628.7. So that is the missing side length here. Alright, next one. Let's start by labeling our triangle. This is the angle we have. So I go right across from it to the opposite side. That has the x, that's what I'm looking for, so I will be using that side for sure. Next, I look for the right angle. I go straight across from it. That's the hypotenuse. Notice they have no information written there, so I'm not going to use that side. The side that's left over, it's right next to the angle. It is adjacent, and it has a number there, so I will use that side. So I'm going to be using 30 and x, which means A and O. The only one that has A and O is TOA, so we are going to be doing the tangent. So the tangent of our angle, which is 65, is equal to, so tangent opposite over adjacent, the opposite is x, over the adjacent is 30. Make this side a fraction 2, and then we can cross multiply. So tangent of 65 times 30, so 30 times the tangent of 65 equals 1 times x, which is just x. Now if I go to solve this, we see that x is on this side all by itself, so all we have to do is just multiply 30 times the tangent of 65. So x equals, if I do 30 times that, tangent of 65 is just a number, I get 64.34. Now this one looked a little bit different. That's just because the x ended up in the top. That can happen with sine, cosine, or tangent. It just depends on the order or which side is missing. That's all. Alright, we'll do a few more where the triangles don't just have the right angle in the bottom left. Alright, always start by identifying the angle. Here's the angle, straight across from it is the opposite side. Look for the 90 degrees. Across from that is the hypotenuse. And then the side that you have left over is next to the angle, it's adjacent. Alright, we are looking to find x, so we're going to want to use this side. And then the only other side that has a number is this side here, so we'll use that one. So that is O and H, which we look for and see that here we have O and H, so we're going to use so. So that would be the sine of the angle, which is 40, equals the opposite, which is 16, over the hypotenuse, which is x. And then let's go ahead and make that a fraction so we can cross multiply. And sine of 40 times x equals 1 times 16, which is just 16. And then we're going to divide both sides by sine of 40 to get x by itself. Sine of 40 is just a number. So then x equals, you do 16 divided by sine of 40 in your calculator, which gives us 24.9. And rounded, so there we go. Alright, start with this is our angle, opposite of it is the opposite side. The hypotenuse is across from the 90-degree angle, and there's a number here, so I'm going to use this side. And then the side I have yet to label is adjacent. It is next to the angle, and that is what I'm looking for, so I'll certainly want to use that side. So I will be using A and H, which means I will use ka. So cosine of the angle 51 equals A over H. A is x, and H is 26. We have two options here. I can draw the line and just multiply by 26 on both sides to get rid of it, or if you like cross multiplying, we can continue to do that. So I put it over 1, and then I multiply 1 times x is just x, which equals 26 times cosine of 51. X is by itself, so all we do is multiply 26 times the cosine of 51, which gives us 16.4. Now, in some cases, when you start your problem and you label everything, you might have information given to you on each side of the triangle, in which case you then have the choice as to which of the three so, ka, or toa you would like to use. So if they give you extra information, there's more than one option. If they only give you two sides, then there's only one right choice. And this concludes lesson 12.1.